And now to a large recall from General Motors. It involves 600,000 vehicles whose V8 engines can fail without warning. TOR engineers have finally cracked open the cause of the engine failures spreading across General Motors, Toyota, Honda, and Hyundai. And what they found inside these engines is not what the manufacturers have been telling you. The National Highway Traffic Safety Administration says manufacturing defects in the engine's components are to blame. The recall covers certain Cadillac, Chevrolet, and GMC models. So it is not bad gas. It is not your driving. It is not contamination. It is something the automakers have been burying for years, and the proof is sitting on a workbench right now in an independent shop most owners have never heard of. By the end of this video, you will know exactly why your engine is on borrowed time. The teardown Berg works alone in a small independent engine shop. No corporate signage, no factory contracts, just a man, a torque wrench, and 3 years of Toyota stonewalling him at every turn. When the failed twin-turbo 6 finally arrived through a private buyer who refused the core exchange, Berg dropped everything. He cleared the bench. He set up the cameras. He started pulling it apart. The main bearings, the ones supporting the crankshaft, were destroyed, shredded, scored, heat burn, total failure. Exactly the kind of catastrophic damage that would end an engine at 30,000 mi and leave a family stranded on the shoulder of an interstate. Berg expected that. Everyone expected that. What nobody expected was what he found. One in a way. The rod bearings fed by the exact same oil circuit through the exact same passages drinking the exact same oil were absolutely pristine. Nowhere, no scoring, no discoloration. Perfect. Sit with that for a second because it changes everything. If debris was the cause, like Toyota has been claiming, both sets of bearings would be damaged. They share the same oil. They share the same passages. Only the mains failing means one thing and one thing only. This was never a contamination problem. This is a design flaw. Maybe the oil passages are too small. Maybe the clearances are too tight. Maybe the bearing material simply cannot handle the load. But design flaws are far more expensive to admit than manufacturing debris. And admitting one would cost Toyota billions. That single teardown is the thread. Pull it and the entire industry starts to unravel. If you are watching this on the side of the road waiting for a Tahoe or sitting in a service bay staring at a 15,000 repair quote, hit subscribe right now. What I'm about to show you is bigger than Toyota. 5 million plus engines from General Motors, Toyota, Hyundai, and Kia are failing the same way for the same reason. And the manufacturers know the disaster by the numbers. Let me hit you with some numbers that should shake every car owner watching this. Pay close attention because your vehicle might be on this list. General Motors, the 7 Tundra vehicles recalled for the 6.0 LVW were 8, but that is barely the beginning. Another 280,000 are now under federal investigation. GM has logged more than 28,000 complaints and over 14,000 of those ended in complete engine failure. Total loss of power, 12 injuries, 42 engine fires, not overheating, not smoke. Actual fireballs under the hood while people were driving their Silverados, Tahoe, Yukons, and Escalades. Family vehicles gone in seconds. Toyota, the brand built on the million myth, V6 engines in 2024, then quietly added another 127,000 in late 2025. Brand new Tundras and 90,000 Lexus LX600 Sequoias hybrids still under investigation right now. The same engine family Eric Berg just had on his bench. Honda 250,000 of their famous 3.5L V6 engines recalled for rod bearing destruction. When those bearings fail, metal shrapnel tear theirs of RPM, and Anetessa just opened a probe into 1.4 million more Hondas dating back to 2016. Hyundai and Kia 1.5 million engines recalled since 2017. And here is what nobody talks about. Some of the replacement engines failed the exact same way as the originals. Add it all up, more than 5 million engines, nearly 8 billion in damages. This is an engine failure epidemic. And the engineers who designed these engines knew it was coming. Physics is fighting back. In December 2025, Automotive News, a publication normally friendly to automakers, dropped a bombshell investigation. They spoke with university engine researchers, independent mechanics who have torn down hundreds of failed motors, and industry insiders who would only speak anonymously for fear of losing their jobs. What those engineers uncovered is devastating. Modern engines are being pushed far beyond what they were ever designed to handle. Automakers are chasing record-breaking horsepower per liter, numbers once reserved exclusively for race cars, packed into engines half the physical size they used to be. In the 1990s, a 6.0 V8 made 360 horsepower. That is 60 horsepower per liter. Today, Ford's 2.7L EcoBoost makes 325 or there's 120 horsepower per liter. The 3.5L EcoBoost in the Raptor made 28 horsepower per liter. Double the power density, same brutal stress, and the oil got thinner. To meet EPA and chaff fuel economy targets, manufacturers switched from 5W3 in 10WD to 20, then UW16 and even UW8, a fluid barely thicker than water. Thin oil saves maybe half a mile per gallon, but it requires tolerances measured in microns, meaning the machining, the cleaning, and the assembly all have to be absolutely perfect every single time on every single engine. Professor Greg Davis stands in front of a teaching engine at the University of Michigan Flint, the kind of cutaway that lets you see every bearing, every passage, every tolerance an automaker is now asking to be perfect. He does not editorialize, he just states the math. Higher pressures create greater bearing loads and accelerated wear. Translation: automakers are demanding the impossible from their own engines, and physics is finally fighting back. Think about what that really means. The engineers who designed your grandfather's truck had room to breathe. Thicker oil, bigger margins, bearings that could absorb a hit and keep going. The engineers designing today's engines have none of that. A single human hair dropped onto a bearing surface could be the difference between an engine that lasts 200,000 mm and one that grenades at 30,000. That is not engineering. That is gambling with your wallet. And it gets worse because there is something else hiding inside these engines from the factory floor. The invisible killer. Stay with this next part because almost no one outside the engine building world even knows it exists. It is called SWARF. Dave from Dave's Auto Center, a master engine builder featured in the Automotive News investigation, runs a shop where every engine that comes through his door gets a level of care no factory could ever match. SWARF, he explains, is microscopic metal debris left behind during the machining process. When manufacturers cut, drill, and hone engine blocks, the large metal chips are easy to spot and remove. The ultrafine particles produced when honing the cylinder walls, those are deadly. Honing creates a slurry of metal dust, abrasive grit, and coolant. Dave calls this slurry concrete. It is brittle, razor sharp, harder than the engine bearings themselves, and it sticks to internal surfaces like glue. Even one microscopic piece of swarf trapped between a bearing and the crankshaft acts like sandpaper at thousands of revolutions per minute. The particle embeds into the soft bearing, then begins grinding into the hardened crankshaft, minutes later scoring, hours later metal on metal, days later total engine failure. Dave's team spends hours cleaning each engine by hand, hot tanks, pressure washing, compressor, scrubbing each oil passage 5 or 6 times. But the problem is scale. GM builds 10,000 engines a day per factory. Toyota, Ford, Stellantis, all the same story. Hand-built perfection at that scale is mathematically impossible. So automakers rely on automated rinses and quick visual checks, and they hope for the best. Powertrain tester Tom Howell, who has spent his career running endurance simulations on production engines, sums it up plainly. Thinner oils, tighter tolerances, and harder bearing materials are all contributing to these failures. Harder bearings mean less forgiveness, less ability to absorb debris, and almost zero margin for error. Here is what nobody tells you. Older engines were actually designed with the assumption that some debris would always make it through final assembly. The bearings were softer, the clearances were looser, the oil was thicker. If a tiny piece of swarf got through, the bearing would absorb it, the oil would carry it away, and the engine would keep running for another 100,000. Modern engines have lost that safety net entirely. There is no forgiveness left in the system. One particle, one bad oil change, one missed start-stop cycle, and the failure cascade begins. Swarf is not the only assassin in there. It is one of 6, the perfect storm. What we are dealing with is not a single design flaw, a single recall, or a single bad engine. It is a perfect mechanical storm, a pileup of modern technologies and engineering compromises all happening at the exact same time. And when you stack them together, today's engines simply cannot survive long-term. Start with the feature everyone hates, and for good reason. Every time your engine shuts off at a red light and restarts, oil pressure drops to 0 for a brief but absolutely critical moment. With ultra-thin Tundra W16 oil, the remaining film of protection on your bearings is extremely thin. Cold starts cause the majority of engine wear, and now drivers are doing 40 to 50 stop-start cycles in a single commute. There is a reason fleet trucks that rack up 150,000 highway miles in 2 years often outlast personal trucks with only 50,000 city miles. They avoid this relentless start-stop abuse. Then there are the oil pumps. Old engines use fixed pumps, simple, predictable, reliable. New engines rely on computer-controlled variable displacement pumps that constantly adjust pressure on the fly. If the pump lags after a start-stop cycle, miscalculates oil temperature, or malfunctions for even a fraction of a second, your bearings get starved. More complexity, more failure points, and it gets worse. Turbocharged engines run at 2,000 plus psi cylinder pressures, double what naturally aspirated engines see. The turbos themselves spin at 150,000 to 200,000 revolutions per minute and depend entirely on clean, properly weighted oil. Any contamination or delayed pressure destroys the turbo bearings, sending metal shrapnel throughout your engine. One turbo failure can kill the entire powertrain in seconds. Now layer in direct injection. DI system spray fuel 2,000 to 3,000 psi directly into the combustion chamber. Great for efficiency, terrible for longevity. Higher combustion pressures mean more stress. No fuel washing the intake valves means carbon buildup. Hotter temperatures mean a thinner oil film. Everything gets pushed harder. Stay with this next part. Engines built between 2022 came out of completely chaotic factories. New suppliers with no track record. Absent quality inspectors, skeleton crews working overtime through the pandemic. GM struggled with out-of-spec connecting rods. Toyota admitted contamination issues. Stellantis even found sand trapped inside engine blocks. These engines are now hitting 60,000 to 100,000, exactly when those hidden defects finally surface. And finally, cylinder deactivation. Turning VAS into V4S sounds efficient on paper. In practice, it creates uneven temperatures across the engine, uneven block expansion, and shock loads when cylinders reactivate under load. Stack all of this together, and you arrive at one unavoidable truth. Modern engines are not failing from one problem. They are failing from 6 simultaneously. No engine on Earth can survive that forever, but 6 factors only explains how the engines die. It does not explain why the manufacturers refuse to admit it. The cover-up Eric Berg's bench again. The teardown is finished, the photos are uploaded, the mains are destroyed, and the rods are perfect. And that asymmetry is the receipt nobody at Toyota wants existing in public. But Berg's engine is not the only one telling this story. Look at Hyundai's Theta disaster. They blamed debris recalled 1.5 million engines replaced them, and the replacements failed the exact same way. That is not dirt, that is design. Watch what happens at GM. Their official fix for the 6-till recall is switching from Zumdo W40 oil twice as thick. If thin oil was not the problem, why is thicker oil suddenly the solution? Because manufacturers know the tolerances are too tight and the thin oil cannot protect these high-pressure engines. But admitting that means lawsuits, billions in costs, and massive regulatory backlash. It is not just GM. Independent shops across the country are reporting that customers are bringing in trucks with knock sensors going off, oil pressure warnings flashing, and bearing noises starting at idle. The dealerships run a scan, find nothing officially wrong, and send the owner home with a service bulletin and a shrug. 3 weeks later, the engine is dead, and now suddenly, there is a recall notice in the mail. The manufacturers know exactly when these engines are failing. They know exactly why. They are running out the clock until the warranty expires on as many vehicles as possible, which raises the only question that matters. If the engineers know and the executives know and the dealerships know, who is forcing them to keep building engines this way? The real villain. The answer is bigger than any single automaker. CAFE standards, corporate average fuel economy regulations. CAFE rules set the average miles per gallon every manufacturer's entire fleet must reach. The targets have been 24 to 2026. Fuel economy requirements rise 8% per year, then jump another 10% in 2026, ending with a mandated fleet average of 49 m per gallon, 49. Meanwhile, your F-150 gets around 20 mb per gallon, your Tahoe sits near 18, your Corvette around 16. There is no mathematical way to hit a 49 mile per gallon average using traditional engines, and the 17 per vehicle for every 1/10 of a mile per gallon. A company falls short. If a manufacturer sells 2 million vehicles and misses the target by just 1 mile per gallon, that is 2 million vehicles, 40 million in fines for 1 mile per gallon, so companies squeeze out every fraction. Tiny turbo engines, thin oil, microscopic tolerances, start-stop, cylinder deactivation, anything to avoid the fines. Engineers did not forget how to build reliable motors. Regulatory pressure pushed designs past what is reliable at mass production scale. What follows is the part that will make you furious. This crisis is not stabilizing, it is about to get dramatically worse. The Trump administration rolled back some CAFE standards in 2025. You would think that would relieve pressure on automakers and help reliability. Wrong. EVs were removed from fleet average calculations. Before this change, 300 mpg gallon equivalent. Those ultra-high numbers offset their gas guzzlers. Ford could sell 15-gun F-150s, 17-gun Expeditions, 16 mpg Mustangs, and evils like the Mach-E and Lightning would balance it all out. They could even buy credits from Tesla. Not anymore. EVs no longer count, but the fuel economy requirement still exists, rolled back slightly to 34 per gallon by 2031. Now automakers have to hit that number without EVs offsetting their trucks. 3 things are coming: even smaller engines, thinner oil, tighter tolerances, more disasters, or massive power cuts. Your next F-150 may drop from 400 horsepower to 250. Your Silverado might tow 5,000 instead of 13,000, or universal hybrids. Every truck, every SUV, every model gets a battery and electric motor. More components, higher prices, more things to break, battery degradation, tanking resale value year after year. And then this automakers are not walking away from EVs. They have spent billions building those platforms. If political shifts in 2028 tighten standards again, they need to be ready. So they will keep using the exact same strategies that caused this entire mess. 5 million plus failed engines, 8 billion in damages. Hyundai alone facing 5 billion for 3.3 million engines, and nothing is truly changing. What this means for real people, this is not just about recalls and statistics. This is about your money, your safety, your family. These failures are happening on vehicles that cost as much as a house: a Silverado High Country 80,000, a Tundra TR Pro 75,000, a Lexus LX600 or 100,000 plus a loaded Escalade 120,000. And the engines are 1,000 to 40,000, sometimes less. Last night a Tundra owner named Marcus in Ohio posted a video to a Toyota owner forum. Is a 2024 Tundra TR Pro 18 months old, 35,000 mi. He was on his way to drop his daughter at preschool when he heard the knock. He pulled into a parking lot. The engine seized before he could turn it off. Tow truck service bay, 2-month back order on a replacement long block. He is still making the further $200 monthly payment on a truck he cannot drive. His wife asked him what they should do. He posted the video because he did not have an answer. Knock at startup, oil pressure drop, catastrophic seizure, tow truck service bay, 2-month wait, repeat. It is the same exact story playing out in driveways across the country. A Silverado owner in Texas, a Sequoia owner in Florida, an Escalade owner in California, a Palisade owner in Michigan. Different makes, different models, different states, identical failure pattern. Some owners try lemon laws. Many states exempt vehicles already under recall. Manufacturers say, "We are fixing it." you are stuck. And remember, Hyundai's replacement engines failed the exact same way as the originals because the design itself was flawed. Now safety. GM logged 14,000 complaints involving complete loss of propulsion. Engines dying mid-drive, 12 injuries, 42 fires, 42 engines caught fire while people were driving their families. Toyota reports stalling and loss of power. Honda's failures involve connecting rod bearings, meaning metal fragments tearing through your engine at thousands of RPM. A rod can punch straight through the engine block or even the hood. Hyundai's Palisade recall warns that a broken valve spring can blow a hole right through the engine. These are not minor issues. These are life-threatening mechanical failures happening in vehicles you trusted with your family's safety. Marcus in Ohio got lucky. He was in a parking lot. The next owner might be in the left lane of an interstate. There is something you can do about it starting today. Steps to protect yourself. Step 1. Get connected. Go to NHTSA.gov right now and use the recall lookup tool. Enter your VIN and see if your vehicle is part of a recall or active investigation. If it is, schedule the repair immediately. These failures often happen without any warning. Fine one day, destroyed the next. Then join the owner communities for your specific make and model. Forums, Facebook groups, Reddit threads. The early warning signs of a brewing recall always show up there months or even years before the manufacturers admit anything. A 100 owners reporting the same knocking sound at the same mileage is not a coincidence. That is a recall waiting to be announced. Step 2. Cut your oil change intervals in half. M intervals, do 5,000 mi maximum or 3,500 if your manual says 7,500. An extra 55 a year in oil changes is nothing compared to a 15,000 engine replacement or a 70,000 truck becoming worthless. Use high-quality oil, Mobil 1 Penso Platinum Valvoline Castrol, and the correct manufacturer spec like Dexos 1 Gen 3. Step 3. Disable start-stop. If your vehicle has a button, press it every single time you drive. Some cars reset the setting automatically. If yours does, a 5000 OBD2 device can disable it permanently. You may lose 0.2 tune per gallon. You avoid dozens of unnecessary wear events every single day. Step 4. Consider slightly thicker oil after warranty. A small step thicker can help. If your Subaru runs a W15 but Japan allows OW and February to run the OW2, if GM now use any duty for the 6.2 tool recall, consider 5W30 after warranty. Do not go extreme, just one grade heavier. Step 5. Monitor your engine constantly. Listen for any new ticking, knocking, or rattling. Check your oil every 1,000 mi. Watch your oil pressure gauge. A low warm. Idle pressure is a major red flag. Step 6. Be smart when buying. Avoid first resigns at all costs. Avoid 2021 to 2024 model years altogether if buying used. Naturally aspirated V8 with 100,000 mi on it may actually be safer than a 2023 turbo with only 30,000. Step 7. Build your paper defense for 2020 to 2024 used vehicles. A 2,000 comprehensive warranty covering engine internals may save you from a 15,000 to 20,000 engine replacement. Read the fine print. Make sure it specifically covers bearing failures and document everything. Save every oil change receipt. Photograph your odometer at every service. Keep records of every dealership visit and every complaint you ever made about engine noise, oil consumption, or warning lights. If your engine fails and the manufacturer tries to deny coverage, that paper trail is the only thing standing between you and a 20,000 repair bill. Follow these 7 steps and you will massively increase your engine's chances of surviving this industry. Wide creases, but none of it changes the math being done above your head. The spreadsheet. Somewhere in a corporate boardroom, in a glass tower in Detroit or Tokyo or Seoul, there is a spreadsheet. On that spreadsheet are 2 columns. One column shows the projected cost of CAF penalties if they build engines the right way with thicker oil and looser tolerances and bigger margins. The other column shows the projected cost of warranty claims, lawsuits, and recalls if they build engines that fail at 30,000. The lawsuits column is smaller. So they build the engines that fail. That is not a conspiracy theory, that is corporate finance. Eric Berg's bench, Professor Davis's teaching engine, Dave's hot tank, Tom Howell's endurance dyno. 4 engineers in 4 different rooms looking at the same evidence, drawing the same conclusion, and one spreadsheet in a room they will never enter, deciding none of it matters. Marcus is still making his Thurs 200 payment in Ohio. His Tundra is still in the service bay. The replacement long block is still on back order, and somewhere that spreadsheet just got updated for the next quarter. Has your engine failed? Drop your story in the comments below. Make, model, mileage, what happened? The more owners that come forward, the harder it becomes to keep that spreadsheet quiet. Smash the like button if you do not want the lawsuits column to stay smaller. Subscribe so the next time an engineer puts something on their bench they were never supposed to find, you hear about it from me first. Thanks for watching.